We are going to take a sample of 10 from a binomial distribution with p is equal to 0.5. To be clear here, what we're doing is a binomial, 10 trials, probability of success 0.5. So if we looked at the expectation of x, that would be 10 times 0.5, which is 5. But we're looking at the proportion, so we're going to be doing 10 times 0.5 divided by 10, which is 0.5. Now it should be clear, if the probability is 0.5, that we would have an expected proportion of 0.5. So that's the bit where we divide by 10 to get the sample proportion. We're going to take 100 such samples and look at the distribution of the means. And there's one example here of how to do this and of the picture that I got when I did it. But we're going to run through that again. So, what we need to do is go to the keyboard and we're going to go to the catalogue again. And this time, randbin. So randbin is going to produce samples randomly drawn from a binomial distribution. So let's copy what's on the screen there. So we've got 10 trials. Probability of success is 0.5. And we're going to take 100 such samples. And then we'll just divide by 10 as we discussed earlier. And let's store that in A. And here we go. Here is our sample. And then we'll go, as we've done before, to the statistics. And it looks like we've got that sample already input into here. So here's A. Just to check that that has worked correctly, I'm just going to go back to main and reproduce that. So the first one's 0.7, then 0.5. Let's just go back into statistics, 7/10, half. Yeah, that looks like it. And so let's just check that our graph's set to histogram, main A. That's all good. And let's do the histogram. And let's make the step 0.1. Remember, for a proportion, it's going to be between 0 and 1. So we're going to do this with 10 bars. And this is what it looks like. And in this case, we can see the highest peak here somewhere around 0.5. And the shape is not bad for a normal. Better than the one I got before. Let's do it again and see if we get another picture like that, or if it's slightly worse, or should certainly be different. So let's do this one. And it's different, but you can see a vaguely normal shape. Now, one of the things to note here is that by taking a binomial 10, 0.5, by having the probability 0.5, we're already starting with a distribution that is symmetric, like the normal distribution. So that's why we're being asked to repeat the experiment with p is 0.3 and p is 0.1. So if we went for a binomial 10, 0.3, and then even more extreme, binomial 10, 0.1, we might expect it to take longer to look like a normal. Of course, the mean's going to be different. So you'd have 10 times 0.3 divided by 10, which is 0.3. So we'd be expecting to see the peak much lower. And for this one, 10 times 0.1 divided by 10 is 0.1. So again, the peak would be more at the bottom end. So let's see what happens if we do that. So let's make this one 0.3 and execute. And now we've got this new sample. Let's go and plot our histogram. I'm going to make that 0.1 again. And you can see, first of all, it looks less normal than the other samples, although this one wasn't that great. And 0.1, 0.2, 0.3, 0.4, the peak is definitely, the higher values are definitely down towards here, and we've got less at this end. Let's just try another one of those very quickly. So see how different this one looks. And go back to statistics. And change that to 0.1. And different, but you can see the peak is here. That's a bit more normal, that one. And let's try it with 0.1. I would expect this to work less well because the original distribution is more skew. So let's go into here. There's a lot of zeros here. And let's make this one 0.05. See what happens. There's a lot at this end, not very much over here. And one thing that I might try, let's just go back to the 0.3 one. Let's take more samples. I wouldn't necessarily recommend this on your handheld because it might take a long time to generate them. And let's just see what happens with that one. Let's take their suggested width. See what that looks like. It looks pretty good. So what did we notice? Well, certainly the 0.1 wasn't great. And it just says here, why do we think this is the case? And I've already mentioned that really. It's to do with the skewness of the distribution. If you start with an original distribution that is symmetric, then it's going to more quickly converge to a normal distribution because, of course, the normal is symmetric.